Okay, let's now get into a couple of your arguments. First of all, you bring up Zeno's paradox, which I find rather absurd. To be perfectly honest, Zeno's paradox was done and dusted when Newton invented calculus. Newton showed with calculus how an infinite number of events can be added up to yield a finite result. Basically, the way calculus works, the way integrals work, is that you can add, you can approximate the answer of an integral by taking rectangles underneath the integral by just taking a number of points along the integral, and then basically what you can do is make that distance shorter and shorter, getting more and more rectangles and getting closer and closer to the actual value of what's underneath that integral. And Newton showed us how that can be calculated, and it in the process did away with Zeno's paradox. You also keep making the claim that an infinite number of events cannot be wrapped within a finite envelope. You keep insisting on that, but I see no reason why it can't. You are talking about relativity, and within relativity you're talking about discrete units of time, which is not correct. Relativity says nothing about discrete units of time. Quantum theory, however, does. Having said that, quantum theory is not the final word on the matter. First of all, quantum theory is described by Schrödinger's equation, which says nothing about discrete entities of time, discrete intervals of time. Yet, something falls out of quantum theory which is called the Planck time, which appears to be like a smallest unit of time below which we can't say anything about reality. What basically happens at that point is that Heisenberg's uncertainty equation overwhelms anything you could say about reality. So for example, when it comes to the start of the universe from the Big Bang onwards, we cannot ever work out what happened within the first 10 to the power of minus 43 seconds after the start of the Big Bang, because that falls within the Planck time and uncertainty is just too great. However, people are working on solutions to this problem, and string theories, for example, do allow to go below that. And you're getting very interesting results, by the way, which you might want to investigate if you ever have the time for that. For example, there are two alternative descriptions of the universe according to, of nature according to string theory, that appear to be sort of symmetrical to each other. The only thing is that one is symmetrical to the other with regard to Planck time. If you were to flip it around and make everything that happens below Planck time inverted as if it were after Planck time and the other way around, you'd get the other theory, which also claims to describe reality as it is. But that then means that basically, somehow mathematically, according to this theory, we can show an equivalence between the first 10 to the power of minus 43 seconds of reality, of this universe anyway, and everything that happened afterwards. And that brings up really interesting philosophical ideas about the nature of time and what is happening there. But I won't go into that. It's just very interesting. What it shows though is that there is no mathematical or philosophical objection to subdividing time into an infinite number of small subdivisions. You can do it, and there's nothing to say you can't. And an infinite amount of time is also not unthinkable if you can accept that time could exist outside this universe, and that this universe is part of a multiverse, where universes spawn off from one another. Nobody can prove that this is so at the moment, but it is theoretically taken very seriously by physicists. And The conclusion I have to take then is that it is possible that such a multiverse does exist, and that it is eternal. It has always existed and it will always exist. So none of those objections can be upheld.